to the Flip-Floperator Auditorium. Coming up next, we have a pre-recorded talk by Julin S. Julin has been working in Python for around 5 years and likes text processing. And will be talking to us now about well-formed Python packages. So we will show you that now. Julin will be in the chat answering questions as the talk proceeds. So feel free to have a chat in there as we go. Cool. Take it away.
Formed Python packages. I'm Julin. Let's get into it. So well-formed package. So what do we mean by well-formed package? It's not a widely accepted term, or it says something that I coined, just as I said. So a package which can be easily modified, which can be adapted for the changing needs. It must be well tested so that whenever we make a change, we need not be worried about if it will break anything that is already existing. So if there are well-written tests for that, we can just run the test and see if everything still works. That's a big advantage. So it ensures ease of collaboration. I mean, others can work on different branches and come in with their changes, and we can there's a well-structured way where we can see if their contributions adheres to certain standards, and we can and well tested and all, and it won't, and we can be sure that it won't break what's already existing, and it's quite readable, stuff like that. So a linting tool, what can a linting tool do? It can tell you, advise you, and inform you, warn you if you're doing something which usually leads to some problematic code, like doing if true, stuff like that. And to a great extent, but not as capable as code tools like Vultr. It can detect dead code, unused imports, syntactical mishaps, and it can advise you as to improving the code readability and consistent formatting, style, linting. It does everything. Pylint, and one more thing, pylint is highly configurable. You can use the pylint.rc file to configure it to your wish. You could say. By default, pylint has 100 character line limit, though PEP 8 mentions 80 or 79, less than 80, I think. So it's highly configurable and there are other tools like Flake 8, which are more lenient, of course, and differs from pylint to a certain extent. So MyPy actually enables a Python program or package to combine the advantages of a statically typed system with the ease of use and comfort of a dynamically typed language in Python. So it actually started out as a variation of a different variation altogether of Python, which was then adapted to make it into a package which works with Python, the CPython code itself, a long time ago. It's been around for a long time, and it uses the type annotations which are being introduced into the Python language, introduced and enhanced many times, to check if the type of the expected type of a variable does not match with the type that it becomes later. It is quite capable and very helpful, as expressed by its use in a lot of packages, prominent ones too. So it's a static analysis of code. It's what it does. So Vultr can be used for detecting dead code, and it will point out an unused code, and of course unused code can often lead to errors which are hard to find. Vultr usually comes in useful, especially comes in useful when in projects which have had a lot of changes along the time, and somehow things things got accumulated, things got a bit messy, and it can be used to detect, find which all code is probably not used, and it has a confidence system. It will say it is this much confident that this part of code is not used, but it may not always be correct. It usually is, it seems, but not always. In contrast to some other dead code detection methods, which are usually dynamically, it actually runs through all the possibilities to see if any coverage is there. Dead code is there. Because it's static analysis. It does static analysis, so it's a lot faster. But the cost to advantage ratio, it's more advantageous compared to the cost it takes. So once we have all the code, source code, as we needed ready, we need to see if it works as we intended it to be. So we test it. So unit testing can be done with PyTest. Of course, there's inbuilt modules, Python built-in modules, unit test, but PyTest is a lot more easier to use and easier to learn as well. So I would suggest using PyTest if you need not use unit test. So the advantage of having test is, as I said earlier, is that if we make more changes into the project as time goes on, we need not be worried, we broke something earlier, maybe we could have broken something earlier. We just run the test that we had and see if it still works even without changes. So having test is a great way to ensure that things all work as intended, despite having made changes to it. So it will, even if we broke something, or if our changes broke something, these tests will probably give us an idea as what went wrong. So what did we do wrong, so we can fix it. So testing is important. So having the test alone is not enough. We have to ensure that these tests cover the entire code base as necessary. So for example, suppose we have a conditional statement. If our if our PyTest test only the if conditions else part and leave the other true part alone, we can't be sure that we did not have the if part works as we intended. So we need a coverage. We need to check the coverage, test coverage, to see if the tests cover all the parts as needed. For that, we could use coverage.py package. This coverage module, it can work with PyTest quite well. Or if you want to use PyTest plugin, there's PyTest code. For the demo at the end of the presentation, I'm using coverage along with PyTest. So once we have our test, ensure proper test coverage, we can use a way to automate all these tests. That's where Talks comes in. It's a test automation tool. We can run whatever test that we want across different environments, different Python implementations, like PyPy, CPython, or anything. Actually, any test that you want, it can run. Any test that can run on a command line, it can be used to run it. So our MyPy checks can be done, vulture test, pylint, everything can be done on Talks. So with just one command, or if you want, there are subcommands can be run separately as well. What Talks does is that it creates a virtual environment on its own. If you enable the build, isolated build, I think, it installs our package into a virtual environment that it creates just for the test, and see if everything works well. So it's isolated, so we can be more sure of its efficacy. So once our tests all pass, everything works well, fine, good, great. So we will need to build and package and distribute so that others can use it. We can share our code, our work, so others can actually benefit from it. So the commonly used tools are setup tools, Flit, and Poetry. Setup tools is for a beginner level, it's a bit tricky to get used to. So I would recommend, at least if you're getting started with, to use Flit or Poetry. For the demo, I'm using Flit because, by the way, Flit can handle only pure Python projects. If you want to see extensions and all, you better go with the setup tools or poetry. And yeah, so Flit can actually build and can be used to publish it to the PyPI or wherever you want. But keep in mind one thing: before publishing to the actual pypi.org, you might want to create an account in test.pypi and publish it there and see if everything works fine. Only then you push it to the PyPI web server. That would be best, so that even if you run into some trouble, you can fix it without going into the production and beyond. The example program that I'm going to show, it's Nims. Nims is a game where you have a set of heaps, which each heap having a number of Nims, something called as Nims. Think of it as a matchstick, if you like. So each heap has a certain amount of Nims. So there will be 2 players. For our example's sake, let's confine it to 2 players. So during each turn, it's the turn-based game. During each turn, the player whose turn it is, will take any number of Nims from any of the heaps. But whoever takes the last Nim among all the heaps is the loser. Other player wins. That's it. Let's see an example here. So we have 2 heaps, heap 0 and heap 1. Heap 0 has 8 Nims, heap 1 have 5 Nims. We have 2 players, John and Jane. So let's say it's John's turn at first. So he takes 2 Nims from each heap 0. So here he goes. Now there are 6 Nims in heap 0 and 5 Nims in heap 1. Jane takes 2 from heap 1. So there is now 3 Nims in heap 1 and 6 in heap 0. Jane takes 6 from 0 afterwards, and only heap 1 has only 1 left. So Jane wins. I hope you got some idea of the game. Let's go to the code demo part now. Let's get started with our demo. For this demo, I'm using Flit for building and packaging. So let's get started. We use Flit init to generate the PyProject.toml file. You arise some questions, just answer them. Julin, my email ID. You can skip these if you like, but I'm entering some of them. I'm using a MIT license. Okay, now the PyProject.toml file has been generated here along with the license. So let's have a look at the PyProject.toml file. It has the information to tell the tool that we are using Flit for building and some data related to that. We will edit some of these options later on. Okay, now we have to generate the directories to store the source code and the test files. Now I'm using an SRC layout. I prefer to play it safer. So let's create them. SRC, Nims, and the test directories. Voila. Oops. Yeah, this is it. Now I'm descending into the source Nims directory and I'm creating 2 files. One's the Nims py file where I will have most of the source code, almost all of the source code, and the init py file to indicate that this is a package. So let's open up the init.py file. In the nims.py file, we define a class Nims. This class represents the entire Nims game along with the data required for it. So the constructor has these 4 values. The heaps is a list of integers where each integer corresponds to the number of Nims in a heap inside the Nims game. So for example, the index 1 of the heaps list corresponds to the number of Nims present in the heap 1. And the same way heap 0 has number of Nims present in heap 0, in heaps of 0, the index 0. Yeah, and n heap is the total number of heaps present in the entire nim game, and max nims has the total number of maximum number of nims possible in a heap. And turn shows whose turn it is, which player's turn it is next. So in our game there are two players, the computer and the user. So the turn value of turn is a string where user corresponds to the user's turn and com corresponds to the turn of the computer itself. And this value, self.total, the total attribute contains the total number of nims present in among all the heaps available in the game. When this value becomes less than or equal to 1, we have a winner and the game is over. Let's next define a function which will change the turn, change the value of the turn attribute after each turn of the game. So we'll call that function changeTurn, the method, and it looks like this. So it's quite obvious what it does. If the value is user, it will turn it into com. If the value is com, it's turned into turn. So just switching the value, that's it. Now let us try running pylint on the program now. The old one is there, okay. Pylint complains, oh, we did not import the random module even though we are using it in the constructor there. So we will import it. And we are missing module docstrings. I hope that's okay. That's a module docstring, and the class needs a docstring as well. Represents Nims game. Okay, these are just random things that I came up with, these docstrings. Okay, let's see what pylint says now. Says trailing new lines in line 23. Let us see. Oh, that doesn't matter really right now. So too few public methods, we will fix that soon enough. So let's move on. Let us create the methods representing the turns of the user and the computer next. So we go here and do this. This comTurn function represents the turn of the computer and the user turn, that of the user. So let us try running MyPy on this at this point. Says nothing, no problem. That's probably because you have not made use of typo notations on which MyPy relies on. So let's do some typing. Let's import some names that we will be using here from the typing module. In the constructor, heaps is a list of integers. Heap is an integer, likewise with the max nims, but turn is a string. So this player has return type already annotated. comTurn returns, as mentioned in the docstring, a tuple of two integers. And the user turn, likewise, same, tuple of two integers. The heap ID, the heap index, and the nim count, the number of nims. So let's try running MyPy again. It says we missed something. Let's have a look what it is. Oh, we have not returned its ID and nims like we were supposed to. If that's the only thing, yeah, my brain has no problems now. No problem now, okay. But something else is missing. Let's try running pylint once again. See, at line 45, there's some problem. It's a static method, it does not use self. So we get rid of that. and pylint is more or less happy. Is happier at least. So we are running out of time, so let's see the rest of the functions. There are 4 of them, I think. Yeah, this function here, play, is actually the driver function. The game loop is present here. This is the game loop. And the next turn function here represents each turn in the game. And this validate function validates the input. This is used only, it's to validate the heap ID, whether the heap ID given as is a valid heap ID is something that exists, and there are enough Nims to be taken, and all those checks will be done in this function. Right now our package looks something like this. So let's have another look at our project.toml file that we created earlier, and tell them that we require a Python version greater than or equal to 3.6, and also mention the development dependencies. We use these packages while developing this package, Nims. Now let us try installing the development dependencies with let install symlink. Yeah, it is there. So let us use PyTest to run the test that we have set up. PyTest passes okay, the tests have passed, but have our test actually covered all the cases that we want to cover? Let us use coverage to check that. Coverage run with PyTest, we are using it with PyTest. Yes, we have, let's see the result of the coverage report. Yes, it's 100%, so it's okay, it works. Now let's use talks to set up, consolidate all this tests into one place so we can actually automate it. And even use different versions of Python, or maybe even different implementation of Python to run all these tests. So let's set up talks.ini file. This is the talks configuration file that I have used. So it uses Python 3.6, 3.7, 3.8, and PyPy 3, another implementation. It's not CPython. And Vultr we used, see if there's any dead code. And MyPy checks we do pylint linting checks, and test coverage we do. And the tests have passed. Let us build the package that we have created with flit build. Before that we have to edit our init file inside the directory, otherwise it won't be happy. Like this, update the version number. It was already done. Expose the class name to the outside world, add the doc string, and that's it. Now build the package with flit build. Now you can publish your package using flit publish. Now I'm not actually going to run this command, because running build by default will try to push to the PyPI server, which I don't want to, and wouldn't be nice to do. But what you could do is configure your PyRC file so that you will kind of push to test.py first. So you can fool around there, see if your package has any problems, fix them, and once you're sure, you can push to the pypi.org server. So we have a package ready. Let's try it out, shall we? I have here an example program. Let's run it. Okay. It's my turn, the user's turn. I will take one nim from first heap. Oh, the computer beat me to it. It took 3 names from heap 0 and 1. Even if it was generating random numbers, it generated the right random number. So that's it. Thanks for being here.